looking at notes U-2 polynomial review. So these are all things that you should know, but you will need to know very well and be able to do very quickly for the upcoming units in pre-cal. So let's refresh. So part 1, multiply. So if I ask you on number 1, like on number 1, to multiply these two binomials, you should be using the FOIL method and you should be doing most of it in your head. So x times x is x squared. The outer and the inner, hopefully you can do together. X times negative 7 is negative 7x, and the inner, 3 times x is 3x. So combine negative 7x with 3x to be negative 4x. And then the last, positive 3 times negative 7, which is negative 21. Okay, so that's your answer on number 1. On number 2, you have the quantity x minus 2 squared. So that means x minus 2 times x minus 2, and again, FOIL. So that'd be x squared with your outer and your inner both being negative 2x. Combine negative 2x and negative 2x to get negative 4x, and then negative 2 times negative 2 to be positive 4. All right, on number 3, you have x plus 5 times x minus 5. So two things. Of course, you could FOIL, so x times x is x squared. The outer is negative 5x, the inner is positive 5x. Those simplify to 0, and then your last would be 5 times negative 5, which would be negative 25. You should have really known this because you should have seen that this was the result of factoring a difference of squares. The x plus 5 and the x minus 5 come from the result of factoring a difference of squares, something you've been working with for a while now. So that's a quick way to think about multiplying back when you have something like x plus 5, x minus 5. All right, so of course I just talked about it, but we're going to refresh again. This was multiplication, this is factoring. So factoring is going backwards from this to this. So factoring the polynomial x squared minus 8x minus 20. So there's no GCF, there's no lead negative, okay? So then you're going to go straight to the t-chart. So numbers that multiply to negative 20, because that a times c, so 1 times negative 20 is negative 20, but add to negative 8. So what numbers multiply to negative 20 but add to negative 8? So your factors of negative 20 are 20 and 1, 2 and 10, and that right there stops us. So 2 and 10 will work if 10 is negative. Since that a value is 1, you can just go straight to saying your answer is x plus 2, x minus 10. Okay, so x plus 2, x minus 10 would FOIL back to this. If I FOILed this, it would get back to that. So this is multiply to negative 20, add, that's an A for add, to negative 8. Okay, with this pen being so fat, it's hard to see the numbers. That's a 2, and that's a negative 10. Okay, so look at number 2. On number 2, hopefully you notice at first, there is no lead negative, but there is surely a GCF. You can not only factor out, so GCF first, if possible. You can not only factor out 3, but each term also has an x. So factor out 3x here, you'd be left with x squared. Factor out 3x here, you'd be left with negative 2x. Factor out 3x here, you'd be left with plus 7. So then you try your t-chart. So multiply to, let me draw this in red now, 1 times 7 is 7. So numbers that multiply to 7 but add to negative 2. So your factors of 7 are only 7 and 1 because 7 is prime. So is there any way, shape, or form that 7 and 1 could add to negative 2? The answer there, that's a comma. The answer there is no. There's no way that that's going to happen. So since that's not going to happen, this is your final answer. You can't go any further. This will not work. Sorry, I'm being a little OCD today, but I want it to look right for you all. So that's a 7 and that's a 1. This doesn't work, so it doesn't go any further than that. So on number 3, again, I talked about it up here. You should notice that's a difference of squares. You could do the t-chart, numbers that multiply to negative 16 and add to 0, since there's no b. But you shouldn't have to do that, especially by now in pre-cal. You should know that that's x plus 4 and x minus 4, which will FOIL back to this. Difference of squares. Difference of squares. All right, so on this last one here for the factoring section, number 4, okay, there is no GCF, there is no lead negative, but our A value is not 1. Okay, our A value is not 1. So you have two choices. You can do the t-chart, where you say you're looking for numbers that multiply to negative 8, but add to negative 7. Okay, so of course it's going to be 8 and 1, where 8 is negative and 1 is positive. You could do this and follow that with grouping, or you could do the guess and check method, which hopefully some of you use and know. I won't show the guess and check method because it does confuse some. I will show the grouping method. So with grouping, since you have that A value in front that's not 1, you would go down to 2x squared, replace the middle with the 2 from the chart. So instead of negative 7x, it'll be negative 8x plus 1x minus 4. So this has been split up into these two, because don't you agree, if you combine negative 8x and positive x, it'll go back to that? The reason you split this up into these two special numbers is because now you have an even number of terms and you can group. So here my GCF is 2x, so factor out 2x from each of these, and you'd be left with x minus 4. On this pair, the GCF is just positive 1. That lead positive tells you take out a positive, so positive 1. So divide both of these by positive 1, and of course they'll stay the same. And now here, this term, I know it's hard to believe, but that is a term. And this term have x minus 4 in common, so it's x minus 4, 2x plus 1. So this would FOIL back to this if I multiplied it out. All right, so that's grouping. So that's section 2 in a nutshell, finished with section 2. So section 3, simplifying rationals. And just remember, the word ratio is in a rational, and ratio really means fraction. So simplifying fractions. So number 1, if you have 3 over x minus 1 minus 2 over x plus 4, how would you be able to subtract those two fractions? Well, just like any other fractions, you have to get that common denominator. So you're going to have to multiply this whole fraction by x plus 4 on top and on bottom, because it's like multiplying by 1, and that's legal. And then you'll have to multiply this whole fraction by x minus 1. So that way your denominators match and you have a common denominator. So of course on the top you're going to distribute. On the bottom you're going to keep factored. Okay, so always remember that. Top you're going to distribute in, bottom you're going to keep factored. So this would be 3x plus 12 over x minus 1, x plus 4, okay, minus 2x minus 2 over x plus 4, x minus 1. But just for sake of keeping these to look exactly alike, we'll switch the order. Remember, that's legal. 6 times 5 is the same as 5 times 6. You can switch those. It's legal. So we switch the bottoms just to show you that they are common. So now that you have a common denominator, you can combine the numerators, keep the denominator the same, just like you do with fractions. 1/5 plus 1/5 is 2/5. Combine the top, keep the bottom the same. So 3x plus 12 minus 2x minus 2 all over that common denominator of x minus 1, x plus 4. So this distributes in, okay, and you get 3x plus 12 minus 2x plus 2 over x minus 1, x plus 4. So clean this up and you get x plus 14 over x minus 1, x plus 4. Okay, so I combined my like terms here, and then of course here, and that's how I got this and this. Kept the bottom the same. So you can see two things. So here on top, there's nothing I can factor out, no GCF, no cleaning up. There's nothing I can simplify with. These binomials must match exactly to cross out. So since x plus 14 does not match either x minus 1 or x plus 4, you have the choice. You can leave your answer like this, or you can put x plus 14 over x squared plus 3x minus 4. Okay, you might see this way, you might see this way. Be prepared to give both. Okay, so that's number 1 in this section. Let's go to number 2. Okay, so number 2. 1 over x squared minus 49 plus 1 over x minus 7. Okay, obviously I don't have a common denominator and I need to get one in order to add two fractions, but this factors. It's a difference of squares, so it's x plus 7, x minus 7. So then to make this denominator match, I would multiply this side, both top and bottom, by x plus 7. So here you have 1 over x plus 7, x minus 7, plus, this distributes, okay, so this would be x plus 7 over, again, I'm going to switch those two because it's legal, x plus 7, x minus 7. Now that you have a common denominator, you can add or subtract across the top, keep the bottom the same. So you have 1 plus x plus 7, add or subtract across the top, keep the bottom the same. Okay, so then this would become x plus 8 over x plus 7, x minus 7. Now remember, nothing can simplify here. The binomials have to match exactly. Or you might see x plus 8 over x squared minus 49. So you might see it kept factored, or you might see it kept multiplied back through. So these are your possibilities for your answers. Okay, number 3. So x plus 2 over x minus 1 plus x over 2x plus 1. All right, so here we have to multiply top and bottom by 2x plus 1. 2x plus 1, it's legal because it's like multiplying by 1. Here we have to multiply top and bottom by x minus 1 to make these denominators match. So here on top, you're going to FOIL. I'm just going to write FOIL. Okay, so 2x squared, that's going to be x, that's going to be 4x, so plus 5x plus 2 when you FOIL over, keep the bottom the same, x minus 1, 2x plus 1, plus, this is just distribution, so x squared minus x over x minus 1, 2x plus 1. Common denominators, so keep the denominator x minus 1, 2x plus 1. Okay, add or subtract across the top. So 3x squared, I'm just going to go ahead and straight up combine. 3x squared plus 4x plus 2. Okay, can this factor to simplify with one of these? Well, let's try. So our multiply chart would look like numbers that multiply to 6, but add to 4. So either 6 and 1 or 2 and 3, will either of those work? Sure won't. So that won't factor. You could either leave it like this, or remember, you have your two choices, 3x squared plus 4x plus 2 over, this would be 2x squared, that's x, that's negative 2x, so minus x minus 1. So you might see either of those two answers. Okay, one more for you, I know. So one more, number 4. Here, this problem factors. So if you do your t-chart, multiply to 12, add to negative 7. So that would be negative 3 and negative 4. So this becomes x minus 3, x minus 4. Okay, so that tells us right here that we need to multiply this by x minus 3, because you've already got the x minus 4. Okay, so this distributes in. Again, it's good to see this subtraction problem. Okay, minus, remember, distribute the 4. So that's 4x minus 12. 4 times negative 3 is minus 12 over x minus 3, x minus 4, just switching the 2 on the bottom. Now don't forget that minus now distributes into both of these. So you have a common denominator, so you'll keep it, x minus 3, x minus 4. This is x minus 4x, which is negative 3x. And then minus negative 12 becomes positive 12. Look what you can do on this one. Factor out the lead negative and the GCF. Okay, if you do that, then you would have x minus 4. On this one, we finally got one that the numerator would factor. Okay, make sure that distributes back. It does, and look what happens. Our binomials finally match. They match exactly. That's the only way that's allowed. And then our final answer on this one is negative 3 over x minus 3. Notice I lost the parentheses. You can lose the parentheses now on the bottom.